Hello everyone, and welcome to another video. It's been a little while since I made a video. I've been away at uni, and although I've been working on the mod, I can only record these videos when I'm back. There's been a couple of big updates actually. A lot of stuff has been added to the mod. A lot of old stuff has been added back in, like the reactors and the fusion reactors. Although someone actually pointed out on GitHub that the fusion reactors in the latest version, which is 2.2c at the time of recording, there's actually a bug at the moment which means that it doesn't actually run. So I need to get that fixed as soon as I get back to the code, which will be in a couple of days, so I'll just get that sorted out. But other than that, things seem to be working pretty smoothly. There was a few glitches and bugs and crash bugs that were happening over the last week or so, but basically all of the known ones have been ironed out. Most of them were to do with the machines, which they're gone now. And there were some other issues with GUIs which have now been fixed. So the only issue now that I know about is the fusion reactor not working, which should be an easy fix. And also that the ores aren't generating in the deep dark from extra utilities, and that should be something that we can do quite easily. So those are the only two major things that are problems right now. And what I want to add next is, well, I want to first of all add back the basics of the particle accelerators. Although obviously the way they worked in 1.7.10 was sort of it wasn't properly added. It was just a sort of demonstration of the concept. But I also want to add a new type of fission reactor, which should be pretty cool, molten salt reactors, but more about that maybe later. Today I want to go through all of the machines in the game, because, well, I didn't really go through them properly last time. Well, I went through a few of them very quickly when I was doing the first sort of video on how 1.10 was going. But I want to go through this now because right now there's no JAI integration, and so people obviously naturally are asking about lots of recipes, especially ones such as the obvious ones like tough alloy, which doesn't seem to have a recipe if you look for it in JAI, just simply because I don't have the integration sorted out yet. Something I'm working on. It's a little bit weird because I've never used JAI before, and it's a little bit different from NEI, so I need to just sit down and really look at it. So I'm trying to balance time working on JAI with actually adding new content. And so far, the content is what you've seen, rather than JAI progress. So I just basically want to go through all the machines and just show you what they do, starting with the basic ones that were already in the mod in version 2.0, and then into the new ones, which involve some fluids of different various forms, and then maybe some newer stuff over there, which wasn't in the 1.7.10 version at all. Right, so let's just start right here. Oh, and then I'm going to make some videos about the fission reactor. And I might backdate to an earlier version of NuclearCraft when fusion did work, just to show off how the fusion reactor works, possibly. But definitely I'm going to do a video on fission. That's the main thing after this. But we're doing this video now. So first of all, nuclear furnace. This is one that's pretty simple. You basically just put some nuclear fuel in the bottom here, like uranium ingots, uranium dust, thorium ingots. You can use the oxides as well. So basically uranium or thorium ingots or dusts, oxide or non-oxide, and basically it's just a furnace that smelts. And I think it's 32 smelts per uranium ingot, and if it's oxidized, then I think it's 48. So very simple. That's just a furnace. Moving on, manufacturing. This basically just is a sort of multi-purpose machine, has many uses. First of all, it can be used to crush up various things, like rhodochrosite into the crushed rhodochrosite, like that. Nether quartz can be made into crushed quartz. Obsidian can be made into crushed obsidian. And diamonds can be made into crushed diamonds, and they're used for various recipes. It's also the way you make graphite. That's quite important. So you can either put coal dust in there, you get graphite dust, or you can actually just put plain coal in there, and you also get graphite. So there we go. That's that recipe. And the final thing it can do is you can put your ores in there, and you can get 2 dusts out. So it works as basically a crusher, effectively. But it's called the manufactory because I might add slightly more, a wider range of recipes than just crush recipes. So any ore that can be converted into a dust and then an ingot should be crushable in here. So there we go. That's pretty simple. Manufactory. Basically a crusher at the moment. Then we've got the alloy furnace. Furnace. This basically just takes in two metals. It's a bit like the induction smelter from thermal expansion. So for example, we got copper and tin. That obviously goes to bronze. That's a classic recipe. What else we got here? Okay, so we've also got some other stuff like, I'm just going to go through the simpler stuff first. Hard carbon, that's 2 graphite and 1 crushed diamond. Hard carbon is not used for anything at the moment, I don't think, although it will be used in more advanced machines. There's also integration for ingots in other mods like thermal expansion, thermal foundation, so Electron, or Tech Reborn as well. And then stuff like Ender IO, which adds steel, electrical steel, I think this makes. I can't really remember. There we go, electrical steel. So it's got other mods recipes in there as well. The main question that's been in everyone's mind, though, is exactly how you make tough alloy. The way you make that is, first of all, you make steel with 1 iron and 2 graphite. That gets you steel. That steel can be used in other recipes from other mods that use steel. So it's very general, that. Steel is then combined with boron to make ferroboron alloy, and that's used in some recipes. And then ferroboron and lithium is then smelted together, and that eventually makes tough alloy. So that's how you make tough alloy, and obviously that's used in loads of recipes. So that's how you make tough alloy. It's you make steel, then you make ferroboron, then you make tough alloy with the lithium. So there we go, that's sorted. Right, isotope separator. This one is pretty simple. This basically just takes in any, well, it can either take in ingots such as thorium, uranium, lithium or boron, and it will separate it into its various isotopes. So thorium goes to 232 and 230. Uranium goes to 238 and 235. And then lithium and boron, which in this version don't actually work. I'm going to add that. I know that's a bug. I'm going to add those recipes. Basically, lithium and boron are going to be used to make the boron 10 and boron 11, and the lithium 6 and lithium 7. So that's how you get those, which are then used in the fusion reactor and various other recipes. So that's going to be fixed. Don't worry about that. That's another thing that needs to be fixed. The other thing you could do is, if you've already made a nuclear fuel and you want to, for whatever reason, you want to disintegrate it again back into its component parts, you can do that in this machine as well. So you can get back the 237 and 236, for example. So it can separate ingots into their isotopes, and it can separate fuels. So that's the separator. Decay hastener just takes in any radioactive isotopes and basically just makes them decay. The decay chain that it follows is exactly as it is in real life. So you're going to get alpha or beta decay. So you can see here we've had 2 alpha decays. Plutonium-239 probably alpha decays to 235, I'm imagining. Yeah, 235. And that probably goes all the way down to lead, actually, at this point. Yeah. So that at the end of the day, everything eventually gets decayed down to lead. So basically, if you want to, for whatever reason, convert to lower forms of the fuel, maybe if you're getting a lot of the higher tier fuels, but you've only got a few reactors that you want to deal with, and you just want to deal with plutonium and uranium or whatever, for example, then this is a good machine. Or if you're just running short on lead, then this is a good option as well. Because obviously any of these radioactive materials eventually becomes lead in this machine. So that's a way of getting lead, which might be good for you. So that's the decay hastener. Fuel reprocessor is a very simple machine. You take your depleted fuels from your fission reactor after you've used them, and this simply basically just extracts all of the depleted products. And these are very various. There's many different products. Some fuels like MOX actually make lots of different colored isotopes, lots of different elements. And obviously these isotopes are then used in more fuels, more advanced fuels most of the time. So TBU, for example, produces some uranium, produces some neptunium, which are higher tier fuels than TBU. So that's the way of basically going up the tech tree. And hopefully this is a lot better system than it was back in 1.7.10. Hopefully you should be getting some very high level tier fuels in a reasonable amount of time. It used to be very, very difficult to go up the ladder, but now it should be easier. Then we've got the electrolyzer. We're moving on now to the slightly more complicated machines. So the electrolyzer, it takes in water and luckily there's an infinite water source block. There's other, obviously any way of generating water, aqueous accumulator, a pump, whatever. Any water will do, but I've got the infinite water source from the mod. I can just place this on top, and that will start producing water and putting it in this tank. And basically the water will just be electrolyzed, so it will separate the hydrogen and the oxygen. And the hydrogen comes in 3 isotopes. So as you can see, well, you can't see right now, but it's producing hydrogen, deuterium, tritium, and oxygen. And these are going to go into these tanks here. So as you can see here, there's hydrogen. We've still got some more hydrogen. That's unfortunate. It looks like this, for some reason, I don't know why. I don't know why it does this. I don't know why it locks it like this. I want to just show that you can extract all of the different fuels from the one side. For some reason, the pipes are a bit weird, but you will see that if you somehow manage to set up these fluid pipes correctly, you can extract all of them from the same side. Not sure what's going on here, to be honest. I think it might be because I think I know why. Actually, I think I know why it is. It's because the way these pipes extract. The way that it gets extracted from the machine means that you have to. It has to be done hydrogen first, then deuterium, then tritium, then oxygen. It's just because basically the thing with these Ender-IO pipes that I don't like is that they don't sort of. There's not a priority system. It doesn't sort of seek the nearest place. It sort of splits up the fluid a bit like the NuclearCraft pipes, except with the NuclearCraft pipes there's filters, and with these there aren't, so it's a bit more difficult to sort of make them. What's going on here now? It's very weird, this. Right, let's try that again. So we've got hydrogen, and now we've got tritium. Deuterium. My goodness. For some reason it keeps doing this. I don't know why it's sort of... There we go, tritium. There we go, there's the tritium coming out. Finally. And then finally the oxygen. Okay, so there we go. So you can extract them all from one side. It's just for some reason these pipes, I wasn't expecting them to be so weird. That was a bit more difficult than I was expecting it to be. But if you use NuclearCraft, it's much easier because you can sort of use filters and stuff, and it works a bit better. So there we go. That's how you get your hydrogen, deuterium, a little bit of tritium. And also, you don't produce much deuterium. As you can see, you produce a lot more hydrogen than deuterium, and especially a lot more than tritium, and then oxygen as well. Okay, so where do you want to use that oxygen? Well, you want to use it to oxidize your fuels, or your fission fuels, because they make them better. You can use the infuser to do that, as well as some other recipes. So the infuser here, we'll just take out a few things. So let's get rid of all this stuff that I wasn't expecting to use. And let's take out some of this stuff. So I've got these creative portable tanks here just to use as my sources. So first of all, let's put the oxygen one on there. Let's fill this thing up with oxygen. So as you can see, it's filled with oxygen there. So first of all, the infuser can be used to infuse isotopes and also the ingots. So for example, I could put... Oh, it doesn't seem to be working. I wasn't expecting that. But this does work. I've got to have a look at that. That's another bug. Obviously, there's a problem there. I need to fix that. But basically, what you would be able to do is make Neptunium-236 oxide. As you can see, the ingots are working, but for some reason this isn't. I wasn't expecting that, to be honest. And you can also oxidize the fuels if you want to. So if you've already made the fuels, then you can oxidize them as well. For some reason this wasn't working. We'll sort that out, don't worry. So there we go, you can get Hep-239 oxide. So that's pretty simple. So that's the oxygen. You can also infuse objects with liquid helium. So this is liquid helium. We'll show how to get that in a second. So there's liquid helium. First of all, you can fill up your coolers with this to finally get your liquid helium coolers. There they are. These are actually very, very powerful coolers. They're worth getting. And then you can also, this ice can be put in here, be infused into supercooled ice. And supercooled ice is used in the recipes for the superconducting supercoolers, so you do need this stuff. So that's how you make supercooled ice, is you infuse ice with liquid helium. So there we go, that's the fluid infuser. Okay, moving on. Let's get rid of some of this stuff. We got the metal melter. The metal melter, it has a various. The metal melter makes it sound like it can only be used for metal, but that's not quite true. It can be used for other things as well, so it might even change the name. I haven't got Tinker's Construct installed, but if you did, first of all, you'd be able to smelt iron ore down into the liquid iron, and gold into the molten gold, obsidian into molten obsidian. You could use you could smelt this into molten glass. All of the Tinker's Construct fluids you could smelt down in this thing. It's also used to make the lithium and boron fluids. So we've got boron 11 here. So liquid boron 11, which needs to be extracted. There we are. So that's liquid boron 11 in there. Boron 10 is again the same thing, and I'll just demonstrate the lithium. Lithium 7 and lithium 6 can be melted down here as well, and there it is in there. So that's used as the fusion fuel. Lithium 6, lithium 7 and boron 11 can all be used as fusion fuels, and boron 10 can be used to generate tritium. So that's that. It can also be used for some of the thermal expansion recipes. For example, you can use it to make liquefacted coal with coal dust. So there's that. You can also use it to make the gelid cryothium. There we go. And the pyrotheum, whatever it's called, the blazing pyrotheum. Resonant ender, I think it's called, or something. There's that. Liquid ender, whatever it's called. It can also be used to make the energized glowstone and the redstone as well. So it can be used for all those thermal expansion recipes. So that's the metal melter. Pretty good. That worked. At least that worked properly. Okay, moving on. We've now got the supercooler. So this is how you generate your liquid helium. Now, liquid helium is incredibly difficult to get. I might have to make it easier because I tried to make a liquid helium factory on a different world, and I made hardly any liquid helium, or at least I generated it so slowly. So I obviously need to maybe rebalance that. But essentially, you just need a source of helium, so a helium collector will do. And this thing will basically just cool the liquid helium. Cool the gas helium and convert it into liquid helium. So there it is. And I think you make, at the moment, as I say, it's quite unbalanced because it's very difficult at the moment, basically. For every bucket of gas helium, you get 4 millibuckets of liquid helium. So it's incredibly difficult to get. But there it is anyway. The actual process won't change. It will, the supercool recipe, this supercool recipe, at least, gas helium to liquid helium will always stay as it is. But it just might be different amounts of each thing. It'll probably just be more liquid helium or something. So, but that's how you make liquid helium anyway. There's also a forestry recipe. In forestry, you can make crushed ice fluid. So if you put water in this thing, you can make ice fluid, which is used as like a combustion engine cooler, I think, or something. So that's another recipe in here, but I just don't have forestry installed. But that's how you make liquid helium. And then finally, the Neutron Irradiator. This is the way you generate your tritium. If you don't want to try and produce it very, very slowly in the electrolyzer, you can produce it from. Well, in this version, there's a recipe missing because I forgot about it. You should be able to use helium-3 and neutrons, but I forgot about the neutrons. I forgot about the helium-3 recipe. That would make tritium and hydrogen. So the only recipes available at the moment in this thing is neutrons with either boron 10 or lithium 6. So let's first of all fill this thing with neutrons. Get that filled up. And then let's fill up with, first of all, let's try the lithium 6 recipe. So as you can see, that starts running. And that will generate tritium and helium in equal amounts. As you can see there, it's filling up. So that's it will hardly use up any neutrons. It will use up a lot more lithium than it does neutrons. So that's the lithium 6 recipe. And then the other recipe is the boron 10 and neutrons recipe. Obviously didn't get enough neutrons in there. There's that. And the boron 10 recipe. That isn't working either. I was not expecting that, to be honest. Okay, obviously that's something else to fix. Very strange how some of these recipes aren't working. I'm actually very confused, but I'll get those fixed. So that's another recipe that isn't working. There's obviously some stuff to work on here, but you get the gist. That's how it's meant to work. So basically the stuff that isn't working, in case you're wondering, is... what was it? It was the stuff that wasn't working was that the infuser couldn't infuse isotopes with oxygen, and the other thing was that boron 10 doesn't work in here. So that's two things I definitely need to fix, because this should work really. And in fact, I thought it was working. I thought I tested this, and for some reason it's not working. Very weird. But I'll fix that. That should be an easy fix as well. Obviously I missed a recipe or made a mistake in the code somewhere. That should be easy. But anyway, those are the basic machines. I will get JI sorted out, I promise. But as you can see, even then there's some work to be done. But those are the basics. Okay, moving on. I just want to show off these again in case I didn't show them off properly last time. There's 4 different types of RTGs in the game, which are basically ways of generating infinite amounts of power. So we've got the Uranium Rtg, which is the easiest one to make. There we go. Which produces 4 RF per tick. That one's just made by with a depleted uranium block, which is pretty simple. Then we've got the Plutonium Rtg, which produces 100 RF per tick. That's made with plutonium-238. The Americium Rtg, which produces I think it's 50 RF per tick. That's made with americium-241. And then finally, the most powerful one, which is the Californium, which is 500 RF per tick, or 400 RF per tick, sorry, which is made with Californium-250. So those are the RTGs. The final continuously power-producing thing is the solar panel. That obviously just works during the day, or most efficiently during the day. And during the day, it produces 5 RF per tick. So that's just another option for solar power, if you don't already have that option already from another mod. So those are the sort of continuously power-producing options for you. Here we have the machine interface. This basically is a way to extend a block if you're running out of side space. This is the manufactory, so obviously this might not be the best example, but say if you've got the electrolyzer or something, and you've got a lot of different pipes coming in from different angles, then you can use this block here as a way of extending the number of sides that you have available. So, for example, you can put items up in here, and you can put them through the manufactory, and you can insert through this thing, and you can extract from the side. Again, this isn't working perfectly at the moment, and I don't actually know why. But basically, I think it's because when you relog into the game, reload the game, it sort of loses track of where this block is, or where the machine is. So obviously I just need to do a check on relog, or on restarting the game, that this thing knows where the manufacturer is. For example, if I try and put coal in here now, if I try and put coal in there, it doesn't really work. But if I take this machine and take a interface and take a hopper and say put it over here, like a fresh one, it then works. So for some reason, on reloading the game, it doesn't recognize properly. But if you place it fresh, it does work. So obviously it is working, but it just doesn't keep track of it properly. This is just a buffer. It's just called the buffer. It's a pretty simple block. Basically, it just tells you all you need to know here. It just stores up to a stack of items, 32,000 RF, or 16 buckets of fluid, and it can be placed in the shell of fission structures. So, for example, it could be placed in here, just like that, and you could say pump some items or power or fluid into the thing, and then you could extract it on the other side. And this is basically a way of getting fluids or items or whatever into the inside of the side of the structure without sort of invalidating the structure. Why you want to do that? You may ask. Well, it's because there's going to be some new types of coolers that are coming into the game, which need to be actively supplied with materials and fluids and things. So that will hopefully make fission reactors even more interesting, needing to like actively supply coolers for them to actually do anything. So this is not to be confused though with the fission port, which is something different here, which is a way of communicating with the controller in the structure. So the fission port is a way of like putting fuel cells in and out of the controller. This is totally different. This is the buffer, which is a way of sort of getting stuff onto the inside of the structure. So that's very different. And you can actually tell the difference between the although they look very similar, you can tell the difference. There is a slight texture difference. The reactor port has this sort of line around the end here, which the buffer does not have. So just keep that in mind when you're looking at fission reactors. So that's the buffer. Now some very, very simple machines that I just added when I was just mucking about. Well, first of all, the helium collector, that's actually something that is important. This basically just generates a constant stream of helium. It generates, I think it was 10 millibuckets per tick of helium. So that's pretty good. So it just generates helium from the decay of this depleted thorium. And there we go, you just generate helium, pretty simple. This here is a really simple cobblestone generator. It is quite expensive, someone did point that out, but this isn't really meant to be entirely useful. It was just basically a test of a concept that I had, which was basically producing or taking in items and sort of using up or constantly producing stuff like fluids, items, energy. For example, I use that in the electromagnets and things like that. It's basically just a general type of sort of passive, continually producing or using block. But if you want to use this cobblestone generator, if you don't already have a cobblestone generator, there we go. It just generates like 1 cobblestone every second, roughly, on average or something. So there we go. That's the cobblestone generator. And finally, infinite water source. Pretty simple. Generates, I don't know how much water actually it generates per tick. Maybe it says here, 20 millibuckets per tick of water constantly. And obviously that can just be used to, do various things. So if you don't already have the aqueous accumulator or other things, then this is another option for you. And that's pretty much all of the machines in the game. So thank you for watching. If you've got any more questions, do comment. Obviously there are a few bugs here and there that need to be ironed out. But overall, it just about works. This mod still is basically in a beta for 1.10.2, so there are going to be some issues along the way. So mainly it's the machine interface that I need to fix, and some of the recipes over here that weren't being registered properly for whatever reason. I did notice actually when I was starting up the server that there were a lot of recipes that were erroring. At least in the server log, there was some error saying the recipe was invalid or something. So obviously I've done something wrong there. But other than that, hopefully you shouldn't have too much trouble at the moment with this mod. A lot of the basics are added at this point. Fusion is sort of there. Obviously there's that bug I mentioned at the start, which is that it doesn't actually run. Bit of a big bug, I will be honest. But that should be a simple fix. I should get that fixed very soon. And then we can move on to adding new stuff. We can move on to adding new fission reactor coolers, active coolers, then active reactors that produce steam, and then steam turbines, and then new types of fusion reactor, like internal confinement reactors, then particle accelerators. So we've got lots of stuff coming, which should be really, really interesting. So I look forward to adding that. But for now, I leave you with the news that I am about to make a new video, which I already explained at the start. It's going to be on fission reactors. It's basically going to be a totally new tutorial, so just totally going over the new mechanics, because there are some very, very fundamental changes. There's a lot of stuff that is very similar, almost exactly the same, but there are some big fundamental differences in the way that the fission reactor works, or at least the coolers work, which I want to go through. And so I want to spend a bit of time on that. So yeah, I'll leave you with that. So thank you for watching, and I'll see you in the next video.